Welcome back. In this lesson, we tackle one of the most important jobs you do as an endpoint engineer, protecting data itself. We'll cover encryption at rest with BitLocker, classification and labels with Microsoft Purview, and endpoint data loss prevention, or DLP. By the end, you'll be able to manage encryption from the command line and design controls that stop leaks without getting in the way of real work. Start with the mental model. Data is vulnerable in 3 different states. At rest, when it's just sitting on a disk. In use, when it's open on a screen or copied to the clipboard. And in transit, when it's moving across the network or being written to a USB stick. A real data protection strategy has to cover all 3. Miss one and you've left a door open. Each state has a control that fits it. BitLocker encrypts the whole volume, protecting data at rest. Microsoft Purview sensitivity labels bind protection to the file itself, so it's covered in use and in transit. And endpoint DLP controls risky egress, copy to USB, upload to cloud, clipboard, print. The key insight: you layer these. No single tool protects everything, so we combine them deliberately. Let's get into BitLocker. It encrypts the entire volume using XTS-AES, the modern tamper-resistant mode, either 128 or 256-bit. The encryption key is sealed to the Trusted Platform Module, the TPM, a hardware chip that only releases the key if the boot process is intact. TPM only unlocks silently, which is convenient. But adding a PIN, that's TPM+PIN, means a thief with a stolen laptop can't extract the key at the pre-boot stage. For high-risk devices, the PIN is worth it. 2 choices matter when you turn BitLocker on. Used space-only encryption is quick and perfectly fine for a brand new drive. But for any drive that has already held data, you must use full encryption, because blocks marked free can still contain readable remnants of old files. And whatever you choose, always escrow the recovery key to Entra ID or Active Directory so a locked-out user is never stranded with no way back in. You'll configure BitLocker across the fleet with an in-tune disk encryption policy, but you verify it on the device. Manage-bde status shows the percentage encrypted, the method, and whether protection is on. Manage-bde protectors -get lists the protectors, the TPM, the numerical recovery password, and so on. And Get-BitLockerVolume is the PowerShell native cmdlet, which is far nicer when you're scripting reports across many machines. Learn all 3, you'll use them constantly. Sometimes BitLocker drops into recovery mode after a firmware update, a BIOS change, or a disk moved to new hardware and asks for the 48-digit numerical password. Because you escrowed it, you simply look it up in Entra ID or AD and unlock the drive. The pro move: before any planned maintenance that touches the TPM or firmware, suspend protection rather than decrypt. The device then boots without prompting, and you resume protection afterwards. Suspend, don't decrypt. Decrypting a whole drive wastes hours. BitLocker protects data on the disk, but the moment a file leaves that disk, the encryption no longer applies. That's where Microsoft Purview comes in. It classifies content using sensitive information types, pattern detectors for things like card or passport numbers, and trainable classifiers, which are machine learning models you train on examples to recognize fuzzier things like contracts. You then apply a sensitivity label, say confidential, which bakes encryption, writes, and visual marking right into the file. That protection travels with the document wherever it goes, even off the managed device. Endpoint DLP enforces policy at the egress points on managed devices, copy to USB, upload to cloud, clipboard paste, and print. Combined with labels, you can say a confidential file may never be written to removable media. But here's the judgment call: if you just block everything bluntly, people route around you, and that shadow IT is itself an insider risk problem. So mature teams start in audit mode, scope tightly by label and group, then enforce with a block with override that captures the user's business justification. You protect the PII without stopping legitimate work. Let's recap. Protect data in all three states: at rest, in use, in transit, by layering BitLocker, Purview sensitivity labels, and endpoint DLP. Always escrow your recovery keys, and suspend protection rather than decrypt before firmware work. Your task: in a test tenant, build an Intune policy enforcing XTS-AES with TPM+PIN and key escrow to Entra ID. Verify it with manage-bde status and Get-BitLockerVolume. Then deliberately trigger recovery and recover using the escrowed key. Finally, publish a sensitivity label. Build an endpoint DLP policy in audit mode that flags that label copied to USB, and write a one-page plan to move it to block with override without disrupting a named workflow. See you in the next lesson.